Going over the OCR Chemistry GCSE Foundation paper, and this is 2020, and we are doing section A. So which separation technique is this equipment used for? Okay, so straight up, this is filtration, and we know this because the dotted V shaped is the filter paper, and this is a funnel, filter funnel, and this is a conical flask, and you would put in your sample over here, and it will be the solid mixing with the liquid, and the liquid can flow through and it's collected over here, so it's filtered into the conical flask, whereas the solid remains in the funnel and the filter paper, and therefore this is called filtration. Crystallization will involve ice or cold water, and so the aim here is to decrease the temperature. Distillation is a much more complicated looking apparatus, so it will not look as simple as this. Evaporation will include heat, and so you increase the temperature, and filtration looks like this. What is the position of carbon in the periodic table? Oh, sorry. So, when you go across, it's a period. When you go up or down, so here, 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 this is a group. And so this would mean that this is period 1, that's period 2, that's period 3, 4, and so on. And when you go down, so this is group 1, group 2, group 3, 4, 5, 6, and so on. So 7, 8, so on. And carbon is over here. So that would mean carbon is in period 2, group 4. Therefore, it's B. Look at the balanced symbol equation. So we have calcium carbonate plus hydrochloric acid making calcium chloride, water, and carbon dioxide. What does the symbol S represent in the balanced symbol equation? Okay, so when it comes to symbols, we only have 4 types. We have S for solid, we have L for liquid, we have G for gas, and we have AQ for aqueous, and that means dissolved in water. And so this is the only types you have, and so S is always solid, and that's why it's A. All these other ones, they're not state symbols. The formula of magnesium chloride is MgCl2. What is the relative formula mass of magnesium chloride? Right, so you look at these and you look at the AR, which has been given, and you add how many times they appear. So magnesium is 24.3 and it only occurs once, so you add 24.3. Chlorine is Cl and you have 2, so we have 2 lots of 35.5. So it's 35.5, you can times it by 2, you can just add it again, 35.5. And so when you add 24.3, 35.5, and 35.5, you get 95.3, and that is B. Sodium hydroxide reacts with hydrochloric acid. Sodium chloride and water are made. What is the name of this type of reaction, right? So hydroxide is what we call an alkali, and hydrochloric acid is an acid. Once you add an alkali and an acid together, this is called a neutralization reaction. Neutralization reaction. And so this is why it's A, because these two are sort of opposites of each other, and so when you put them together, they neutralize. Oxidation reduction, so you're thinking of oil rig. So oxidation is the loss of electrons, and reduction is the gain of electrons. So what you're looking here is for any change in electron number. And that's when these would count as oxidation or reduction. Thermal decomposition is when you heat. So usually you have maybe one reactant, and you'll be told in the question it's heated up and it forms products. This is thermal decomposition. So you most likely see this with a carbonate. So you put a carbonate under heat and it will break up. And that says A. Neutralization occurs when acids react with alkalis. What is the ionic equation for the neutralization? So ionic just means when the ions are involved. And you put them into equation, so it's called ionic equation. And so neutralization, because if we go back to this previous example, this is a neutralization reaction, so we have sodium hydroxide, so this is what it looks like. And we have hydrochloric acid, and this is what it looks like. So you know that the alkali is an OH and an acid is a H. And an OH is always negative because sodium is a metal, so it's positive, and therefore this is negative. And chlorine is a non-metal, so it's negative, and therefore the hydrogen is always positive. And so it's always a positive hydrogen and a negative hydroxide. And this is the answer. Butane has a molecular formula C4H10. What is the empirical formula of butane? So empirical just means the simplest. And in order to get this, we have to break down the butane into the most simplest form. But that means it will have to have whole numbers of the atoms it has here. So both can divide by 2, so we get C2H5. Because I have a negative here, I cannot divide it any further, because if I divide by 2 over here, then I'm going to get a decimal. And you can't have decimals in empirical formula, always has to be whole numbers. And therefore, the simplest form is C2H5, which is B. Ammonia has a simple molecular structure. Which statement explains why ammonia has a low melting point and a boiling point? Okay, so this is what ammonia looks like. It's NH3. So ammonia is NH3. And this is called the covalent bond when the atoms are connected together. But ammonia doesn't exist as one molecule, it exists as lots of molecules. This is with everything else. So this is how things exist in real life. And they're also connected with each other like this, and this is called an intermolecular bond. So the intermolecular forces, because it's not a bond, it's a force. This is a bond, and the force is dotted because they're not actually bonds, they're just forces. And these are the ones that you'll be breaking in order to go from a solid to a liquid or a liquid to a gas. And the more that there are, the stronger they are, and the harder they are to overcome. And so if there's a lot, you'll have a high boiling point or high melting point. If it's fewer, then you would have low melting point and boiling points. So these usually determine the strength of the simple molecule. And it's not the covalent bonds, it's the intermolecular forces. And because ammonia has a low melting point and low boiling point, we say that the intermolecular forces are weak. Therefore, the answer is D. Ethanol C2H5OH burns in oxygen, carbon dioxide and water are made. Which equation for this reaction is correctly balanced? Okay, so if we have C2H5OH and we're burning with oxygen, so oxygen is always O2, and we get carbon dioxide, which is CO2, and water, which is H2O. We need to balance it out. So let's start off here. We have got 2 carbons, and here we only have 1 carbon. So to balance it out, we need to add 2. So our carbons are balanced. Hydrogens, we have a total of 6 over here because we've got 5 plus 1, so it's 6 hydrogens. And here we have a total of 2 hydrogens. Therefore, we have to add 3 because 3 times 2 is 6. So now our hydrogens are equal. And now let's look at our oxygens. So we have a total of 3 over here oxygens because that 3 applies to the O as well. And we've got 2 times 2 lots of oxygen, so 2 times 2 is 4. So we've got 4, 5, 6, 7 total of oxygens here. And here, therefore, we have 4, 5, 6, 7. And here, we need to make a total of 7 oxygens. Oh, sorry. Total of 7 oxygens on this side. So if we make this to a 6 and we have a 1, so we have 7. And so if I write 3 over here, that gives me a total of 6 oxygens plus the 1 over here, making me a total of 7. So all I had to remember was that I can minus 1 oxygen and make this an even number because then I can add it on. So 3 times 2 is 6, plus 1, 7. And the answer is B, because that's the same as that. The diagram shows an atom of an element. What is the name of the element? Okay, so the elements on the periodic table are written in terms of the number of protons, which is equal to the number of electrons. So It's hard over here to count the number of protons, but we know they're equal to the number of electrons, and we can just count the electrons easy. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. So we've got 9 electrons. That means we have 9 protons. So 9 protons. And we're going to look for a number that has 9. As we can see, fluorine has 9, and therefore our answer is fluorine, which is C. An aqueous solution of concentrated sodium chloride is electrolyzed. Bubbles are seen at the positive electrode. What is the name of the substance produced at the positive electrode? Right. So we have sodium chloride. The sodium is the metal, so it's a positive charge. Therefore, it will go at the opposite, so the negative electrode. Chlorine is a non-metal, it's negative, therefore it goes at the positive electrode. Therefore, the answer is chlorine, which is A. A potassium isotope can be shown as this. So 39/90. What are the number of protons, neutrons, and electrons in this potassium isotope? So protons equivalent to the number of electrons, unless it's an ion. And number of neutrons, so we've got protons and neutrons make up the mass number. So this is the top number. Therefore, the number of neutrons would be mass number minus the proton number. So the bottom number is a proton number, so automatically you can see it's 19 protons. So it says incorrect. So it's 19 protons, and that's equivalent to the number of electrons. So 19 protons gives you 19 electrons, unless there was a charge here indicating that number of electrons is not equal to the number of protons. And there isn't, so 19 protons gives you 19 electrons. And we have to minus these two numbers together to get the number of neutrons. So 39 minus 19 gives you 20, so 20 neutrons. So that's why the answer is B. Oxygen reacts with 1.2 grams of carbon. 4.4 grams of carbon dioxide is formed. What is the mass of oxygen used in the reaction? Well, there's only one product and it's telling you it's 4.40, and we've got 1.2 grams of carbon. Therefore, we've had to add our oxygen here to make up 4.4. So if we do 4.4 minus 1.2, that gives us 3.20. Therefore, that's how many oxygens we used. So the answer is C, because once you add this and this, they need to make the same mass as shown over here. The symbol of aluminium is Al3+. The symbol of an oxide ion is O2-. What is the formula of aluminium oxide? Okay, so we've got Al3+ and O2-. We have to make them both the same. So what number can we multiply with so we can get them to the same? So both can go to 6. So for example, if we do 3 times 2, we get a total charge of +6. And if we do oxygen and we times it by 3, then we get a charge of -6. Once the charges are the same number, then they are correct. So that means we have 2 lots of aluminiums and 3 lots of oxygen, so that's D. And that's how you work it out. Another way you can do this, instead of doing it this way, is switching the charges. So for example, we have Al3+ and O2-. We need to switch the charges. So the Al is 3, so that means we need to have 3 oxygens, and the oxygens is 2, therefore we need to have 2 aluminiums, and that gives us Al2O3. So it's called switching charges. So the charge means that's how many oxygens you need, and the charge over here means that's how many aluminiums you need. Substance Y melts at -7 degrees Celsius and boils at 59 degrees Celsius. What is the state of substance Y at room temperature? So room temperature is usually 25 degrees Celsius, and we know that at -7 it melts, and at 59 degrees Celsius it boils. Therefore, before 59 it must be a liquid, and it melts, yes, and after 59 it should be a gas, and this whole time it is also a liquid, and before -7 it will be a solid. So room temperature is over here, so it will be a liquid. So it's B. No, plasma is not a state. So only solid, liquid, and gas. And so that's it.